Hello there. I want to share with you a story of how I managed to improve the performance of a parser that I built. First, a little bit of a backstory. So, as some of you might know, I'm working on something I call the time traveling debugger, which sort of works by basically taking the snapshot of the state of the program at every single step that the program takes. So to give you an example, if you so this tic-tac-toe game has been written in a programming language that supports this debugger, and if you play the game against the computer, like so. There's actually a bug here. I don't know what the bug is. I'm not gonna bother trying to debug it. That's not the point of this video. I was trying to click on this empty square and it didn't take for some reason. I'm gonna ignore that. The point is, as it's going through the steps that are required to carry out this game, it actually logs the snapshot of the game into this history array. If I use this copy command, I could copy this history object like this, and then I would end up with I'm on Mac, so there's a program on Mac. There's a command line program on Mac that allows you to access your clipboard, which is pb paste and pb copy. So if I do pb paste, I paste this JSON string that I copied, which is in this JSON-like format. And this is not exactly JSON because this is actually in a format called jsonr. It's JSON with refs. So the point of it is you can give an ID to any object or an array and then later on refer to that exact same object or array via the ID. So this and defines this object to be 1, and then this *1 refers back to that same object. So it's possible to have references in this JSON-ish format. Okay, so that's basically the context. The jsonr library contains a parser for parsing files of this format, and the snapshots that we're taking, we've serialized them into a file of this format. And I've had trouble with the performance of the parser. In particular, when I was working on the Zoom debugger, which works by first loading in a file in this JSONR format using the JSONR parser. In some cases, it was taking more than a minute to parse the file. So I was really annoyed because every time I had to work on this piece of software, I had to wait. Every time after I change my code, reload the browser, I have to wait for a whole minute, and that's just unacceptable. So I had a very huge motivation to fix this situation. So basically, I played a game like this, and then I captured the history of that came from a game, and I saved it in a file. I called it tic-tac-toe 700k because this file is approximately 700k in size. And if we look at it, it is in this JSONR format, and you can see some of the objects or some of the variables that are used in the program as represented in this format. I'm going to show you 4 versions of the parser. I have a branch for each of the versions. I'm going to start with version A. So in all but one of the versions of this parser, the parser was written in Nearley.js. I have I have made videos on Nearley.js and how to use it to build a parser. So if you're not familiar with Nearley.js, that's where you can get to learn more about what it is. If you are already knowledgeable about Nearley.js, then there's something I need to tell you. Okay, if you're using a repeating pattern, such as an array, this is members, this is actually objects. So object is a repeating pattern, just as arrays are, because objects can have any number of members within it. So an object consists of the opening and closing brackets, and then members. What is members? Member is one single member, which is a string followed by colon and followed by an element. But there could be multiple members delimited by a comma, like that, right? So initially in version A of this parser, it was written in this way. So we're saying, what's a members? A members is first a member, and then a comma, and then more members. Because the symbol to the right-hand side is referring to the original symbol, members. This is a recursive rule. So I'm gonna generate this parser, take this grammar and generate it to produce a JavaScript file, and use that to parse this 700K file. Let's actually time this execution here. On Unix, you can use this time command right before the actual command you want to execute, and at the end, it will tell you how much time it took to actually do that. And while it's going, I'm actually going to read for you an article on the Nearley.js website. Under the article called How to Grammar Good, one of the sections is called Don't Shy Away from Left Recursion. If you, I'm going to read this for you. If you were a good little student and you paid attention to your professors when they told you never to write grammars like A goes to A and then something. This is left recursion, as in contrast to the right recursion that I used. And I was being a good little student, because indeed my professors told me to not recurse on the left and recurse on the right. And the reason is, in other types of parsers, in particular recursive descent parsers, which I do plan to cover in the future, but with recursive descent parsers, this left recursion simply will not work. So, but he's saying Nearly, of course, is much better, so you don't have to worry about that. He's saying if you're paranoid about efficiency, you should actually prefer left recursion over right recursion, because it's very slightly faster. In any case, that's how you deal with left or right associativity for binary operators. He's saying if you're using Nearly.js, instead of doing recursive descent parsing, then you should actually prefer doing left recursion, which I did not do because I was following the best practices of, the more conventional way of writing parsers, which was to do recursive descent, as we were traditionally taught. Anyway, okay, so that process finished, and it actually took 2 minutes and 10 seconds. Let me actually write this down here. When you're doing performance analysis or very complicated kind of debugging, you should keep your notes. So I'm gonna make a file. I'm gonna call this perf numbers, and it's August 24th. Okay, so this was ran on version A on the file. The file was called tic-tac-toe 400k.history. I also want to note how many lines were in this file, tic-tac-toe history file, using the wc command, and it told me that there are 45,320 lines. Okay. So version A gave us this performance. It's saying user time is actually 3 minutes and 20 seconds. I'm not sure what is actually the more better time for me to use, but system time, I guess system time is just the time that the operating system took. Real time refers to actual elapsed time. User and sys refer to CPU time used only by the process. If anyone watching who understands why user time is more than real time, please enlighten me on that. In any case, so version A of my code, this was the state it was in, and it, as you can see, it took like more than a minute, in this case 2 minutes, just to parse that humongous file. I learned that not just from Nearley.js, this Nearley.js article, but also from another article, which I might link, but I have to go dig it up. Learn in detail about the early parsing algorithm, that left recursion should indeed be preferred. How much should it be preferred? Well, I will let you decide after you see the result of switching to left recursion. So I'm gonna bring out version B of this code. And version B of this code, we switch from right recursion to left recursion now. The sort of symbol to the left of this comma is referring to itself, as you can see. So now I'm gonna regenerate the parser and then rerun this test. And it took 5.9 seconds. User time is 7.7 seconds. So I'm actually curious. So I'm gonna print out the date before and after this command. 24 and 18, it's about 6 seconds. Maybe the real time is more correct. So anyway, I guess the important thing is version B with left recursion. Version B is much faster. How much faster is it? Well, 2 minutes and 10 seconds is 190 seconds. It's divided by 5.9 seconds. 32 times faster. Version B is, just by switching to left recursion. So I would actually say this word very slightly faster, that's a huge understatement and perhaps a little misleading. I think you should recommend left recursion much more strongly than that. Okay, the next optimization that I tried, because even 6 seconds is still not that great. I ideally want things to be like under 1 second. The next thing I tried is adding a lexer. I did make a video about how to use a lexer along with Nearley.js. This version does not do that. It does not use a lexer, but version C does. So let's switch to version C. And for those of you watching at home, I want you to take a guess as to how much difference it would make to use a lexer versus not a lexer. And to give you an intuition about what Elixir does, it takes a string, say string like this, where each character is in a square like this. Okay, what Elixir does is groups them, so this string block gets grouped into one token. This left brace is its own token. This is a colon, and then this string gets grouped into a string, and this right brace. So instead of working with every single character, the parser doesn't have to do that. The parser can work with these individual tokens. The Lexer as a pre-processing step has done one step of the work of grouping these things together, such as string literals or numbers as well. So that's what Elixir does for you with regenerate the parser. Let's rerun this test with the time command. And we do get an improvement. We improved to about 4 seconds for the parse. So version C with Lexer improves to 4 seconds. How much faster is that? Well, it's that divided by 4.026. So 1.47, let's say 1.48. Not as dramatic an improvement as the left recursion fix, for sure. And then after version C, I tried one more version, but this version requires a larger departure from this code base. Because I actually rewrote the parser from scratch using recursive descent. More specifically, using a technique called functional parsing, or at least partially inspired by functional parsing. There is a video on Computer File talking about it, and that's where I learned it from. So the version D is the version that uses this functional parsing parser. And to give you a sense of the code, I built up a bunch of building blocks for building the parser, which look like sequence, choice. Choice is for it's like an or in a grammar. Like choice is like you either choose this path or this path, whereas a sequence is like you first match this and then match this and then match this. So with a bunch of small building blocks like this, you can write the grammar in a very declarative fashion, almost like a grammar in this format. But in terms of the functions that are implemented to support these things, I wrote them by hand, and I'm not gonna explain them at this point, other than saying that it is using the recursive descent method to do the parsing. But yeah, so this is the code. Let's see what the performance is. The performance is much better, actually, using this method. So version C, version D, functional recursive descent method. How much is it faster? Well, it's 0.647 now, so this divided by 0.647 is 6.2 times faster. Okay, and if you want to compare the original performance, which was 160 times 2. Oh, I think I did the initial calculation wrong. 60 times 2 plus 10, 130. Let's do divided by 0.647. 135 times, wait, no, 200 times faster than version A. I think I did this calculation wrong though, so this should be, for this 32 times faster, I think I did this one wrong. This should be 21 times faster. Okay, 21 times faster than version A. So the fastest one is the recursive descent one, which was written from scratch without using a parser generator tool such as Nearley.js. It would seem that this method is what you should prefer all the time, although I would say it's not as clear-cut as that. You don't necessarily always pick the tool that's most performant. There are other considerations too. For the case of Nearley.js, there's a couple of big benefits to it in my opinion. One is the ease of using this grammar, the ease of learning how to write grammars like this without sort of learning exactly the internals of how the parsing algorithm works. Another benefit of this is the you don't have to worry as much about infinite recursion and stuff like that, whereas with recursive descent there are some grammars that just cannot be supported because of infinite recursion. If you don't do it the right way, then there's infinite recursion. And also the Nearley.js, we've been able to figure out really nice ways to do error reporting with Nearley.js, which we have not figured out for the recursive descent method yet, although I am planning to work on that sometime in the future. I think the biggest takeaway with performance work is measurement is really important. You don't really truly know if what you did gave you better performance unless you have a very specific way of measuring it and a very specific data to measure it with. Although one caveat to that is that the performance techniques that you use that really work for your specific case may not work as well in a different scenario. This is possible. Another thing is more specific to parsing and even more specifically to Nearley.js is you should always prefer left recursion over right recursion. That actually makes a very, very big difference. And using a lexer will also help, although not quite as dramatically as the left recursion situation. So if you have a limited time to work on performance, I would definitely recommend you go for the left recursion. And finally, if you hand-coded your parser, you can actually achieve even greater performance. So that's all I have for you in this video. Thanks for watching.